Спасибо.
Делать добрые дела просто. С приложением Google.
Welcome to today's talk. It's Sunday the 19th of December. Now I want to do a bit of an update on some science from Hong Kong University which has got a lot of impact on the Omicron wave at the moment. But before we do that, I just want to notice that the Omicron variant is now 60% of the cases in England. That means only 40% are now Delta. Now, last week, Professor Chris Whitty said that the Deltas were staying the same and the Omicrons are on top of that. Now, whether that's still the case or not, we don't know. I am expecting Omicron to displace Delta, but no definite news that that has happened yet. Now, we're looking at about 90,000 new cases per day in the United Kingdom. So that means that the actual infections are probably going to be 4 or 5 times that. At least that was the data with Delta. So with Delta variant, the infections were 4 or 5 times the cases. So let's just clarify what we mean by that, because I've been guilty of confusing you on this myself, so my apologies. So infections are the total number of people that get infected in a particular area over a particular period of time. And the cases are the ones which are actually diagnosed. So the cases are always going to be less than the infections. So cases are subsets of infections, because a lot of people with infections won't realise they are infected, or won't bother getting tested, or will misattribute their symptoms and not realise they need to get tested. So the actual infections in the UK at the moment, probably we're looking at several 100,000, maybe 300,000 cases per day. This is really taking off, and it will be the same in the United States in just a few weeks' time, I have no doubt about it, and all over Europe as well. Now, there are increasing hospital admissions that have been diagnosed with Omicron, and most of these are in London. So the last couple of days there's been about 200 admissions per day in London. Now that sounds like quite a lot, but apparently about half of these admissions, they have been diagnosed with Omicron, but they were admitted for something else. And this is the same as the South Africa situation. Now once they're admitted with someone else, they have to be treated like COVID patients, and they go on the COVID statistics. But it's not really that representative. So what it means is there's so much Omicron infection in London at the moment. If someone's admitted to hospital, there's a pretty good chance they're going to be, or there's a reasonable chance they're going to be infected. So about 50% of the Omicron patients diagnosed in hospital in London with Omicron at the moment were incidental findings, not admitted for that reason. Now the other thing I just want to mention briefly before we go on to today's science is Sajid Javid has been on telly, the health minister. He says 10% of the eligible population are still unvaccinated. And he said these unvaccinated people account for 9 out of 10 of the most ill in hospital. Now, he doesn't say what most ill means. He's probably referring to patients in high dependency or intensive care, but 90% of the most ill patients in hospital are unvaccinated. So that's an interesting statistic to ponder when you're balancing risks. Most ill people in hospital are unvaccinated. And he says that the 5 million adults that are completely unvaccinated at the moment in the UK are causing a damaging impact, because they're taking up beds that could have been taken up by someone else with a heart condition or the other backlog of conditions we've got. So just a few things to ponder there. But the main number there is 60% Omicron new cases in England now, and the rest of the world is either there or is following. Hospital admissions in the UK, about 7,500 patients in hospital at the moment in the UK. The number of people that actually have Omicron that we know of in hospital so far is 85. Now that's 85 out of 7,500 with Omicron. Of course, we don't have full data on that. That was based on numbers from yesterday, but that's where we are at the moment. So looking like a fairly similar situation to South Africa, where a lot of people in hospital with Omicron were diagnosed with Omicron in hospital rather than being admitted for complications of Omicron. So that's quite interesting. Now let's go straight on to some science that I wanted to cover today. So here we see, this is the bronchial passage here. So this is the lining of the bronchial passage here. And this is the wall of the bronchus. Now this is tightly packed with cells here. All these little blue dots here are cells composing this mucosa, as we call it, of the bronchial passage. And there, it's probably, you can't really see it on this, but that sort of fluffy area there, that's called the brush border, and that is actually the cilia, these wafting hairs that waft the mucus up and down the bronchus. So as we said, that's the wall of the bronchus there, that's connective tissue. And that is actually the cilia, these wafting hairs that waft the mucus up and down the bronchus. So as we said, that's the wall of the bronchus there, that's connective tissue. Now, just before I tell you why I'm telling you that, well, I'll show you why I'm telling you this. This is research from the University of Hong Kong. So the Hong Kong University of Medicine finds Omicron SARS coronavirus 2 can infect faster and better than Delta in human bronchus. So we're in the bronchus here. Now what we have, of course, most of you will know this, but we have the trachea taking air down down through the neck, and that divides into the right and left main bronchus. And then these subdivide, so the left one here initially subdivides into 2 main passages. This subdivides into 3 main passages, going to the lobes of the lungs, and then these carry on subdividing into smaller and smaller bronchial passages that are what we call the bronchial trees. So this is like a snapshot. This thing we've looked at here is a snapshot of this lining here. And of course the lung tissue is here. This will be the lung tissue here. That will be the lung tissue there, where the bronchial tree is taking air into the lung tissue. And the lung tissue is largely the small microscopic alveoli, not drawn to scale, of course, because these are actually millions of these in the microscopic. So that's what we're talking about. Now, the red bit here, the red bit that we can see here, this is the marker for the virus that these researchers have identified. But the key thing they've identified is that the virus is being found in large numbers, replicating in large numbers in the bronchial passages. So that's in the, they don't say the trachea, but I would assume it's the trachea as well, but the bronchial passages, the right and left. So that's the main bronchus. These are the lobe of bronchi, and the smaller bronchi go to the segments of the lungs. So they're finding this infection in here in the bronchial passages, as opposed to, and this is the vital point, as opposed to they're finding much less actually in the lung tissue. Now with the first waves, the wild type and the delta type, the problem was, of course, that we have the small airways in the lung here, the microscopic airways, these alveoli, these like hollow bunches of grapes, these large surface areas from which gaseous exchange takes place. So normally the oxygen should go in that direction into the blood. The carbon dioxide should go from the blood back into the alveoli. And the problem was these were filling up with fluid. These were filling up with fluid and patients are basically drowning. That's called lung consolidation, which is basically a form of pneumonia. So that's in the, they don't say the trachea, but I would assume it's the trachea as well, but the bronchial passages, the right and left. So that's the main bronchus. These are the lobe of bronchi, and the smaller bronchi go to the segments of the lungs. So they're finding this infection in here in the bronchial passages, as opposed to, and this is the vital point, as opposed to they're finding much less actually in the lung tissue. Now with the first waves, the wild type and the delta type, the problem was, of course, that we have the small airways in the lung here, the microscopic airways, these alveoli, these like hollow bunches of grapes, these large surface areas from which gaseous exchange takes place. So normally the oxygen should go in that direction into the blood. The carbon dioxide should go from the blood back into the alveoli. And the problem was these were filling up with fluid. These were filling up with fluid and patients are basically drowning. That's called lung consolidation, which is basically a form of pneumonia. And that was the problem. But it's looking like with Omicron, rather than the virus getting down here and multiplying down here in the lung tissue, the virus is actually multiplying in the bronchial passages, so causing more of a bronchitis than a pneumonia would be the hope. Now, having understood that, let's look at what they're saying in this research. So this is the first information on how Omicron SARS coronavirus 2 infects the human respiratory tract. So we're getting down to some proper science now. Omicron infects and multiplies 70 times faster than Delta in the human bronchus. So here, in the bronchial passages, the Omicron is dividing 70 times faster than the Delta, meaning we get massive numbers of viruses generated here. Therefore, massive numbers of viruses are going to be breathed out really, really quite quickly. And of course, they're going to infect the next person who comes along. And as we saw the virus there breeding, for want of a better word, the virus reproducing inside the cells of the bronchial passages in the bronchial tree. So this very rapid proliferation of the virus in the bronchial passages easy to breathe out, very large numbers being produced, being breathed out in very large numbers, which may explain why Omicron may transmit faster. Well, it certainly may explain that. So that's at least one of the factors. Omicron infection in the lungs is significantly lower than the original SARS coronavirus 2. So it's not getting into the lung tissue here as much. So that means these alveoli, we are hoping, stay nice and hollow so the air can get in and out without getting this severe acute respiratory syndrome that was the characteristic of many of the earlier deaths. That's the hope. So the Omicron infection in the lung is significantly lower than the original SARS coronavirus 2, which may be an indicator of lower disease severity. So this is the sort of scientific reason why it may be, or it's looking like, Omicron is less pathogenic than Delta. More to come on that, but this is consistent with an optimistic outlook at the moment. The research is currently under peer review, so it's not peer reviewed yet, but the University of Hong Kong wouldn't publish complete nonsense. Now, they pioneered the use of ex vivo cultures in the respiratory tract. So we're familiar with in silico analysis, where it's inside a computer modulation. We're familiar with in vitro analysis, where it's inside glassware. In vitro literally means in glass. Basically it means on the laboratory bench. We're familiar with in vivo, which means actually in life. But ex vivo, ex means outside of life. So this is where some lung tissue has been taken out of a patient, usually for medical reasons. And that lung tissue has been cultured outside. So it's kind of halfway between in vivo, which is life, and in vitro, which is in the lab. So it's ex vivo, literally out of life. So bits of proper human lung tissue, but analysed on the bench is what this new technique is. So it's ex vivo, and Hong Kong University has been pioneering the use of this ex vivo cultures of the respiratory tract for the investigation of emerging viruses since 2007, and they are, as far as I know, the leaders in this ex vivo culturing. So they take out, basically they'll take out, the patient has to have a bit of lung removed for some clinical reason, or so the patient will have a bit of lung taken out, and then they'll culture up that bit of lung on the bench, and then that means they've got tissue from the lung tissue itself, from the alveoli, and they've got tissue from the bronchial passages, so they've got tissue from both, and they can culture those and then see how they interact with the virus. And if you think that's pretty clever, so do I. It's pretty impressive applied science. So lung tissue removed for treatment of the lung from surgical cases. And then they've got tissue from the bronchial passages, so they've got tissue from both, and they can culture those and then see how they interact with the virus. And if you think that's pretty clever, so do I. It's pretty impressive applied science. So lung tissue removed for treatment of the lung from surgical cases. Dr. Chan and his team successfully isolated the Omicron SARS coronavirus 2. So they've successfully isolated the virus. Now, more on that in a minute. I'll just leave that hanging for now. They've successfully isolated the virus and used this experimentally to compare infection with the Delta variant. So they've cultured the Delta variant already. They've isolated the Delta variant. And they've now got these tissues, so they've got some lung tissue and they've got some bronchial tissue basically lying in essentially Petri dishes. I'm sure it's a bit more sophisticated than that. So they can put on Omicron and see how it interacts with both tissues, and they can put on Delta and see how it interacts with both tissues. And that's what they've found, that the Omicron is reproducing much more quickly in the bronchial passages, but reproducing much more slowly in the lung tissue, in the alveoli itself. So it's looking good so far. 24 hours after infection, Omicron variant replicated around 70 times faster than the Delta variant in the bronchial tissue. I mean, wow. Wow. 70 times faster. That's incredible. 70 times faster in the bronchial tissues. Quite amazing. So it's breeding really quite prolifically, or reproducing quite prolifically in these bronchial lining tissues. And that bit there, of course, is the air. That's where the air is going in and out. Wow, what a massive rate of viral replication, absolutely huge. In contrast, the Omicron variant replicates less efficiently, about 10 times slower in human lung tissue compared to the original SARS coronavirus 2. So there you go, Omicron is 70 times quicker to reproduce in the bronchial passages, in the upper airways. But the lower airways, where it's more likely to cause severe pathology, it's reproducing 10 times more slowly than, at least than the original variant. Impressive differences and impressive numbers, which may suggest lower severity of disease because it's breeding more slowly or reproducing more slowly in the lungs. Dr. Chan, of course, is a scientist, he qualifies this. It's important to note that the severity of disease in humans is not determined only by viral replication, but also by the host immune response to that infection. So what he's saying is, you can have viruses